Now we will discuss descriptive statistics, numerical measures. We will discuss measures of location and measures of variability. So if the measures are calculated for data from a sample, they are called sample statistics, such as sample mean, sample median, sample standard deviations. If the measures are calculated for data from a population, they are called population parameters. Since populations are usually large, you can't exactly calculate the population parameters for most cases. In that case, you select the subset of the population, you select the sample, and calculate sample statistics to estimate a corresponding population parameter. For example, you can calculate sample mean to estimate the population mean. And in that case, a sample statistic is referred to as the population and point estimator of the corresponding population parameter. So if you calculate sample mean to estimate the population mean, then sample mean is the point estimator of the population mean. And we will discuss first measures of location and then measures of variability. And we will discuss mean, median, mode, weighted mean, geometric mean, percentiles, quartiles. And the mean is the most important measure of location. It provides a measure of central location. It is the average of all the data values. So X bar is the sample mean. Mu is the population mean. How do we calculate the mean? This is a sigma. This means summation. Sum xi's. What is xi? Xi's are the observations in the sample. So it is sum of I1 to n xi over n. What is n? Sample size, number of observations in the sample. Xi's are the observations. For example, if we have such as 46 class size data for a sample of 5 college classes, 46, 54, 42, 46, 32. Now the X bar, so these are the observations. So the first observation x1, x2, x3, x4, x5. Then sum of xi over n. So this means we sum all the observations. The sigma means sum. N is 5. Which is 44. That's the sample mean. Average of all the observations. You add them up divided by total number of observations. The formula for computing the mean of a population remains the same, but we use different notation to indicate that we are working with the entire population. So the number of observations in a population is denoted by capital N, And the symbol for population mean is mu. Now we have 70 efficiency apartments were randomly sampled in a college town, and monthly rents for these apartments are listed here. Now how do we calculate the sample mean? We have to add all the observations, all these 70 apartment rents divided by 70. So the mean is 590.8. What is the median? Median is the value in the middle when the data are arranged in ascending order. It's the middle value. If you have even number of observations, median is the average of middle two. But first thing you need to do is arrange the observations in ascending order. And if we have an extreme values in the data set, the median is the preferred measure of central location. Because, for example, property values or the salaries, there may be few extremely large incomes, or the property values can inflate the mean. In order to calculate the mean, you include every single observations, and such as property values and extremely large incomes or property values can inflate the mean. So that's why if you have extreme values in the data set, a median is the preferred measure of central location. So what is the median here? So median is not 12, because first we need to arrange it in ascending order. We can so median is not 12 here. First arrange it in ascending order, and then the median is the middle value. So we need to first arrange it in ascending order. And if we have even number of observations, now again we first need to arrange it in ascending order and then average the middle two, which is 22.5. If you have odd number of observations, then median is the middle one. And if you have even number of observations, median is the average of middle two once you arrange it in ascending order. Here, what is the median? We have 70 observations. So median is average of middle two already in ascending order, so which is 575. That's the median, because they both 575. So we discuss mean, median. Now trimmed mean. What's trimmed mean? You obtain the trimmed mean by deleting the smallest percentage of the certain percentage of smallest and the largest values from a data set and computing the mean of the remaining values. For example, you can calculate 10% trimmed mean. This means you remove the smallest 10% and the largest 10% of the data values. Then calculate the mean of the remaining values. Trimmed mean is preferred if we have extreme values in the data set. What is an extreme value? Unusually large or unusually small value in the data set. And trimmed mean is a compromise between mean and the median. To calculate the mean, you include every single observations, which average of all observations, and to calculate the median, you trim the maximum amount. So you ignore everything. You just take the either average of middle two or just get the middle one. This means you trim the maximum amount. So the trimmed mean is compromise between median and the mean, somewhere in between median and mean. To calculate the mean, you include all observations, but for the median, you eliminate everything, just get the middle one, or the average of middle two. So trimmed mean is somewhere in between. What is mode? Mode is the value with greatest frequency. You can have more than one mode in a data set. For example, here, mode is 550. So if we look at 525 only occurs one time, 530 occurs two times, 535 five times, 545 times, but 570 occurs 7 times, and we don't have any other value that occurs 7 times. So we only have one mode, which is 550. 550 occurs 7 times. Sometimes we cannot just calculate the simple mean, because each observation may have different relative importance. So they may not have equally important, they may have different relative importance. In that case, we cannot just simply calculate the mean. We need to calculate the weighted mean. For example, GPA. For example, they would like to calculate the GPA. Such as A, history B, English B, A. So this is 4 credit hour, history 2, 3 credit hour. So A, so this means it is 4, B 3, now how can we calculate the GPA in this case? We cannot just add these grades and divide it by number of courses, because they don't have equal credit hours. For this student or for this major, math is more important than history, or finance is more important than English. So they don't have all equal credit hours, so we cannot just add these grades and divide it by number of courses. We have to calculate the weighted mean. Now how do we calculate the weighted mean in this case? And the choice of weights depends on the application. In this case, since we are calculating the GPA, which the grade, credit hours are the weight. So we multiply grade by credit hour. And add them up. Which is 40. Now divided by what? So how do we calculate the GPA? Now 40 divided by total credit hours. Total credit hours, which is 11. So then the GPA is 3.6363, so 3.64. Two decimal, it is 3.64. The choice of weight depends on the application. So which is sum of, we have sigma sum, this means sum of weight times the observation. This is what we did here. Weight credit hour times the observation grade. We add them up, got 40, divided by sum of the weights, which is sum of the credit hours. This is how we calculate the weighted mean. And the choice of weight depends on the application. Such as here, another example, Ron Butler, a home builder, is looking over the expenses he incurred for a house he just built. For the purpose of pricing future projects, he would like to know the average wage he paid the workers he employed. And listed below are the categories of workers he employed, along with their respective wage and total hours worked. So he would like to calculate the average wage he paid the workers he employed. So we cannot just simply average these wages, because they all work different hours. We have to calculate the weighted mean. So we multiply the average wage per hour times the total hours worked, add them up, divided by sum of the total hours worked, because they all work different hours. So we multiply average wage times hours, add them up, divided by sum of the hours worked, so which is 20.05. Geometric mean is used in analyzing growth rates in financial data. So in that case, using arithmetic mean will provide misleading results. And how do we calculate the geometric mean? By providing the nth root of the product of n values. So you can use the geometric mean anytime you would like to determine the mean rate of change over several successive periods. It's the product denoted by x bar g, product of nth root of the product of n values. So you have n values, you multiply those and take the nth root. But taking nth root is same as raising it to the power of 1 over n. Such as square root of 4 is same as 4 to the power of 1 over 2, which is, so as you can see here, which is 2. Or fourth root of 16, which is also 2, is same as 16 to the power of 1 over 4, which is 2. So how can we calculate the geometric mean of these values? We multiply those 0.94 and take the fifth root, because we have 5 observations. Now we will discuss the percentiles. There are different procedures to calculate the percentiles. We will discuss the procedure that Minitab uses. So the percentile provides information about how the data are spread over the interval, from the smallest value to the largest value. Admission test scores for colleges and universities are frequently reported in terms of percentiles. So the p-th percentile of a data set is a value such that at least p% of the items take on this value or less, and at least 100 minus p% of the items take on this value or more. Now, how do we calculate the percentiles? This is just the location, to find the location of the p-th percentile. P is the percentile we wish to calculate, n is the sample size. For example, how many observations do I have? 12. So then n is 12. Now we will find, say we wish to calculate 80th percentile. Now we will find the location, which is 80 over 100 times 12 plus 1, which is 0.8 times 13. $10.4. Now what is the 80th percentile? So now we return the data. So this is just the location. So then 80th percentile. So what does this tell us? This means that 80th percentile is somewhere in between 10th and the 11th value. Which one is the 10th value? 40, 50. And which one is the 11th? 41, 30. Now how do you find the 30th, 80th percentile? We take the 10th value, 10th observation, 40, 50, plus, because of this 0.4, we are doing the interpolation. It is somewhere in between 40, 50 and 41, 30, but it's slightly closer to 40, 50 because this is 10.4. So 0.4 times the difference, which is 41, 30 minus 40, 50. Which is 40, 80. 82. That is the 80th percentile. So this is how we calculate the percentiles. Now here, 80th percentile, we locate it. P over 100 times n plus 1. Here the sample size is 70, so 70 plus 1, which is 56.8. So this means the 80th percentile is somewhere in between the 57 and the 56. This is the 56, it is in ascending order, and this is the 57th observation. Now we take the 56th one, which is 635 times 0.8 times the difference, 649 minus 635. So now it is 80% of the values take on a value of 646.2 or less, and 20%, at least 20% take on a value of 646.2 or more. Quartiles are specific percentiles. They partition the data into four equal segments. We have three quartiles: first quartile, second quartile, and the third quartile. So they partition data into four equal segments, three quartiles: first quartile, median, third quartile. First quartile is the 25th percentile, second quartile is the 50th percentile, which is also the median, and the third quartile is the 75th percentile. Now here, how do we calculate the third quartile, which is the 75th percentile? So first we locate it P over 100 times n plus 1. So then 75th percentile, which is the third quartile, so 75 over 100 times 70 plus 1. This is just the location. This is not the 75th percentile. This tells us that the third quartile is somewhere in between 53rd and the 54th values. In this case, they both 625. So it's 625 plus, because of this 0.25 times the difference, but it is 625 because they both the same. Now we will discuss measures of variability. We don't just look at the measures of locations, we also look at the measures of variability, especially if we have two or more variables to compare. Measures of variability, which is the dispersion. We will discuss some measures of variability: range, like range, variance, standard deviation, interquartile range, coefficient of variation. Now, what's the purpose of the measures of variability? Again, for example, we have two suppliers, such as supplier A supplier B. These are the delivery times. For the supplier A and the supplier B in terms of days. Now they all have the same, what's the average delivery time for supplier A? which is 5. Average delivery time for supplier B, it is 5 too. But which supplier would you like to work with? It's supplier A, because it is more consistent. So we don't just, the variability dispersion is less in supplier A, which means it is more consistent. So we don't just look at the measures of locations, we also look at the measures of variability, especially if we have 2 or more variables to compare. Now, which measures of variability is we will discuss here: range, interquartile range, variance, standard deviation, and coefficient of variation. What is range? Which is the simplest measure of variability. Very easy to calculate, which is the difference between the largest value and the smallest value. Max minus mean. Maximum value minus the smallest value. It is very easy to calculate, but it is very sensitive to the outliers. Your largest value may be an outlier, your smallest value may be an outlier. So then range is very sensitive to an outlier. And also you don't utilize all the information. You only take the maximum and the smallest minimum value, and you ignore what is in between. Well, it is very simple to calculate. Now here ranges, so largest value is 715, smallest value 525, which is 190. Another measure of variability is the interquartile range. Interquartile range is the third quartile minus the first quartile. It is the range for the middle 50% of the data. An interquartile range is not sensitive to extreme data values because it is, so you ignore the largest, like 25% of the largest and the 25% smallest values. It is just it is like the range for the middle 50%. So it's not sensitive to outliers, but still you are not using all the information. You are just taking the third quartile and the first quartile. So this is the first quartile, third quartile. Interquartile range is the difference between the third quartile and the first quartile. Not sensitive to outliers, because if you have outliers either towards this end or they are this end, you have outliers an unusually large or unusually small value. So interquartile range is not sensitive to outliers, but you are not utilizing all the information. It is like range for the middle 50%. Variance is a measure of variability that utilizes all the data. You need to know how to calculate the variance. For a sample, it is based on the difference between the value of each observation and the mean. And it is useful in comparing the variability of 2 or more variables. So if you have one data set, you calculate the variance. May not make sense, but if it is useful in comparing the variability of 2 or more variables. For example, you may have more than one supplier. You would like to calculate the variability in delivery times. So you can calculate the variance for each supplier and compare it, and select the one that is more consistent. Let's see how to calculate the variance. Like 46. 54, 42, 46, 32. Here the mean is, we already calculated the mean, 44. How do we calculate the variance, which is sample variance is denoted by S square. And how do we calculate the sample variance? It is again, so we have sigma here, this means we will sum. What do we need to sum? Xi minus x bar squares divided by n minus 1. I1 to n xi minus x bar squares. So let's calculate the variance for this example. So xi's, are these observations, 46, 54, 42, 46, 32. So if we look at this, look at the formula, what do we need to do? We need to take care of the inside of the parentheses first, which is xi minus x bar. What does this mean? This means we subtract the mean from each xi. What are those xi's? Observations. So we subtract the mean from each observation. So then 46 minus mean is 44, which is what? 2. 54 minus mean 44, 10. 42 minus 44, negative 2. 46 minus 44, 2. 32 minus 44, negative 12. So we have summation here, but do we need to sum these values? What do we get if we sum these values? 12, negative 2, 2, so this is 0. 12, negative 12, 0. Sum of the deviations from the mean is always 0, so we don't sum the xi minus x bar. Sum of xi minus x bar is always 0. We need to square these first and then add them up. So we took care of the inside of the parentheses. Now we need to square those values. So we square xi minus x bars. So now 2 square, which is 4. 10 square, 100. Negative 2 square, 4. 144. Now we add these values. So what do we get if we add those values? $256. Now the variance is So now we took care of the numerator. 256 divided by n minus 1. What is n here? N is 5. Divided by n minus 1, which means 5 minus 1, which is 4. So then 256 divided by 4, which is 64, is the variance. So the variance is the average of the square deviations between each data value and the mean. For the sample, it is xi minus x bar square, sum of xi minus x bar square over n minus 1. So first you need to calculate the sample mean, then subtract the mean from each value, and then square those, add them up, divided by sample size minus 1. Population mean is denoted by sigma square, which is sum of xi minus mu. Mu is the population mean, square divided by the population size, n. So the variance uses all the units. It's the measure of variability that uses all the data. But variance doesn't have the same unit as the data. If unit for the data is hour, then unit for variance is hour squared. So it doesn't have same unit as the data, so then it makes it difficult to interpret. Standard deviation, which is the positive square root of the variance, which has the same unit as the data. And standard deviation is denoted by S, sample standard deviation. It has the same unit as the data. It's the positive square root of the variance. So if we go back our example, so what is the standard deviation here? Square root of 64, which is 8. Now the other important thing about the variance and the standard deviation, so variance can never be negative, so standard deviation also can never be negative. So because even if so you get xi minus x bars, even if you have negative values, you square those and they become positive. So variance can never be negative, so does the standard deviation, because standard deviation is a positive square root of the variance. Another question is, can variance be 0? Theoretically it can be 0, such as if all these values are same, say they all 46, 46, 46, 46, 46, then variance will be 0 if they all the same. Can standard deviation ever be larger than the variance? Such as if standard deviation is 0.25, then what is the variance? 0.25 square, which is 0.0625. So this means, in this case, less than the standard deviation. It can be less than standard deviation, but variance can be less than standard deviation, but it can never be negative. We will discuss the coefficient of variation. Coefficient of variation indicates how large the standard deviation is in relation to the mean. In some situations, we may be interested in a descriptive statistic that indicates how large the standard deviation is relative to the mean. And this measure is called the coefficient of variation. So standard deviation divided by mean times 100%. This is a useful statistic for comparing the degree of variation from one data series to another even if the means are drastically different. For example, you may have mean x bar, say 80, standard deviation 12, and you may have other 0.5, standard deviation 0.2. Now, which one is more variable? So the B has less, the standard deviation for B is less than the A, but mean for A is also a lot less than the B. Mean for B is also a lot less than the A. So in order to compare these, we need to calculate the coefficient of variation. So now 12 over 80 times 100%, which means 15%. And now the B, the coefficient of variation, 0.2 over 0.5 times 100%, which is 40%. So now coefficient of variation for the B is higher. So then the coefficient of variation, which means the B is more variable. The coefficient of variation helps us to see that even a lower standard deviation doesn't mean less variable data. And it is so simple to calculate and helps us understand the relative variability. And it is also unitless, so you can compare the variability, compare the degree of variation from one data set to another, even if the means are drastically different, like in this case. Now we will see how to obtain descriptive statistics using Excel. Now we will see how to use Excel to calculate the descriptive statistics, numerical measures, like we discussed, mean, median, mode, first quartile, which is 25th percentile, or we can say 25th percentile, third quartile, 75th percentile, how do we calculate the mean? Which Excel function we use? We simply use the function average. So hit equal, average, and you select the data. $590.8. 590.8. Or you can select this data and give a label to data. For example, do you see A2 here instead of this one? You can say apartment, rent, and we don't have to select it each time. Now the median, we say median. Now is apartment rent here. It automatically selects it. 575. Median is 575. Mode, mode is 550. Mode 550. First quartile, $545. 75th percentile, which is the third quartile. So it's in the function it tells you, so you select the array, then comma, then select which quartile, which now we want third quartile, which is 625. And the range is the maximum largest value minus smallest value. Range is 190. It is 190. Interquartile range is the third quartile minus the first quartile. It is 80. Interquartile range. Variance. So variance estimates variance based on a sample, which is the sample variance. Variance is 2996.16, and the standard deviation STDS which is square root of the variance 54.74. And you can format this. You can go format cells, number, decimal place, 2 decimal is good. You can, these are descriptive statistics, numerical measures. This is one way to do it, or you can go to data analysis, descriptive statistics, input range, which is selected here. Select the range. Now we have a label in the first row. New worksheet. You can either select an output range in the same worksheet, or you select new worksheet and here select the summary statistics and hit OK. Here it reports the mean. Standard error is, we haven't discussed this, it is the standard deviation divided by square root of the sample size, which is count 6.54235. It reports median, mode, standard deviation, variance. Kurtosis, we haven't discussed kurtosis. We haven't discussed skewness yet. It reports the range, minimum, maximum, sum, which means sum of all observations, and the sample size. We will also, next we will discuss measures of distribution shape, measures of relative location,